Okay, let's talk about classes and objects in C#. Let's start with a Java class to refresh our memory about some terminology. In Java, we can group classes into packages. From a class, we can create objects like this one, which is an object of the circle class. Sometimes we also say an object is an instance of a class. Inside class, we have fields like ID, ID seed, radius. We also have methods like getID, getRadius, setRadius here. We also have a special type of methods called constructors. They look like methods, but the name is the same as the class name, and there's no return value. Constructors are used to initialize the created object, like this one, which sets a value to ID and a value to radius. Fields, constructors, methods, and properties of a class are oftentimes called members of a class. If all the objects of a class share the same member, that member is called a static member, like this ID seed field here. And the keyword this refers to the current object. And the last but not least, we have access modifiers like private, public, and so on. All these are pretty straightforward, except for property, which needs a bit more explanation. First of all, it's important to know that properties and fields are not the same thing. In Java, properties are defined by getters and setters. For example, in our circle class, the getID method defines a read-only property ID. Note that A, the property name, is lowercase id, where the first letter is capitalized in the getter. And B is called a read-only property because there's no setter for ID. Similarly, the getter and the setter of radius defines a property radius, and this time it's a read and write property. In Java, it doesn't actually matter much if you consider these properties or just regular methods because you use them as regular method calls. But in languages that are based on Java, like the expression language used in JSPs, we can actually access properties with the same syntax as for fields, with object name, dot, then property name. This shows that properties are indeed something different, not just getter and setter methods. So why do we want properties? The short answer is that we want something that look and behave like fields, but we also want some additional control on how they are accessed. In particular, sometimes we may want them to be read-only or write-only, and sometimes we may want to perform some additional logic when they are accessed. So far we've been talking about Java. What about C#? Well, all the things we talked about so far are the same in C#. All the terminology, the meanings of keywords like static, this, and so on are exactly the same in C#, except for two things. First, package is replaced by namespace. We talked about namespace in a video earlier. Basically, it's the same as package without the requirement that the name has to match some folder structure. The second difference is more important. C# has explicit syntax for properties rather than defining properties implicitly with getters and setters. This would be what the circle class look like in C#. We'll have a namespace with the class inside, and everything else is pretty much the same as in Java, except for the properties, both in terms of how the properties are defined and in terms of how they are accessed, and also the naming convention. In Java, fields, methods, and properties use camel case, where the first letter is in lowercase. In C#, as we mentioned before, anything public uses Pascal case, where the first letter is in uppercase. So now that we have a big picture view of C# classes, let's talk about some details, starting from access modifiers. Here are the access modifiers in C#. Public and private mean what they mean in Java. Anything public can be used anywhere, and anything private can be used only in the same class. Protected means something can be used in the same class and its subclasses. C# also has an internal access modifier which doesn't exist in Java. Internal means something can be accessed from the same assembly. Assembly in C# means either a .dll file or a .exe file, which is the equivalent to Java files in Java. Equivalent to jar files in Java. If something doesn't have an access modifier, it counts as a default modifier. The default for types, meaning things like classes and interfaces, is internal. The default for members is private. For example, here, there's no access modifier for the program class, so by default, it's internal. However, for the main method, it's default to private. C# constructors are basically like Java ones. A constructor with no parameter is called a default constructor. If a class has no constructor, the compiler will automatically create an empty default constructor for the class. A constructor can call another constructor. In Java, we would have this as the beginning of the method, but in C#, we have it as part of the method header like this, after a column. There are two terms associated with creating objects. Instantiation, meaning to create an object by calling a constructor, and initialization, meaning to put some values into the object. Here's an example with these two separate steps. First, we call a constructor to instantiate an object, then we initialize it with some value. Same thing here, except that we are calling a different constructor. And this code is basically the same as what we would write in Java. In C#, we have an additional syntax called object initializer, which basically combines instantiation and initialization into one. You can see that the syntax is quite similar to the array literal syntax we saw before. So you can call it object literal if you want. It starts by creating an object by calling new constructor, and then followed immediately by a pair of braces, and inside are the properties and fields we want to initialize. There's a special case here. If the constructor used is the default constructor, we can drop the parentheses like this. Two things about C# object initializer. First, it's quite a popular way to create objects, so you'll see it used a lot, and you should get comfortable using it yourself. Secondly, there are a few things in C# that have similar syntax, and it's easy to get them confused. You may want to compare object initializer, array initialization, and named arguments side by side to see the similarities and differences. Okay, now property. If I have to pick one thing about C# class to focus on, it'd be property, because A, the syntax is quite different from Java, and B, you'll use it all the time. This is what the syntax of a full C# property looks like. First, we would have a private field, which is usually called a backing field because it backs a property. The name of a backing field usually starts with an underscore. This is a naming convention, not a requirement. We then declare the property based on the backing field. The name of the property followed by the getter and/or the setter of the property. The syntax is obviously different from Java getters and setters. In particular, they don't use regular method syntax, and there's no method name. There's no parameter list or return type. And because there's no parameter list, in the setter, there's a special variable called value, which contains a value passed to the setter. As in Java, a property can be read-only, write-only, or read-write, depending on whether it has a setter or a getter or both. Now let's do a quick example and see how it works. First, we'll create a class and we'll call it circle, and then we'll create the radius property. It's kind of difficult to remember the syntax for a full property. So in C#, we can use something called a code snippet to automatically generate this code. The name for full property code snippet is prop full. So we can do prop full and then tap the tab key twice. Now it creates a property for us, and let's rename it. We'll call this one radius, and the property will be called capital case radius, and we'll change the type to double. Okay, now we have our property, and just like in Java, we can create a circle object, and then we can assign the value to the property, and we can print out that value. And if we run this code, of course, we see 2.5 here. It's a simple example, but I want to use it to show A, the syntax of writing a full property, and B, how properties are accessed. Notice that instead of calling a setter to set the property value or calling a getter to get the property value, we can access a property using the same syntax as accessing a field. But behind the scene, it does call the getter and setter with whatever logic we put in the getters and setters. So most of the time, we actually don't have actual logic in property getter or setter. And in those cases, instead of using the full property syntax, we can use the so-called auto-implemented property like this. So instead of doing this, we can simply say public double radius and get and set. And that's it. The rest of the code works like before. A couple of things about auto-generated property. First, we can use this syntax for read-only property, but not write-only. For example, we can do something like this, but we cannot do something like this. And the second, for read-write property, both getter and setter must be auto-implemented, meaning that we cannot have a separate getter and then auto-implement setter, or we have a special setter with auto-implemented getter. That is not allowed. In that case, we'll have to use the full property syntax. And one more thing about property. Remember we talked about expression-bodied methods. Basically, one-line methods that can be simplified into an expression with a lambda operator. We can, of course, do that with property getters and setters in the full property syntax, because after all, they are still methods. One additional thing we can do is to use the same syntax to create a read-only property, like in this example. Suppose we have two fields, underscore first name and underscore last name. Then we can combine them into a read-only property called name, like this. Please pay attention to the syntax and note the difference between an expression-bodied method and an expression-bodied property. Specifically, if this is a method, we would have a pair of parentheses here, and then we would use it like user.name parentheses. This would be a expression-bodied method, but here it's actually a property without the parentheses. So later when we use it as a property. Okay, moving on. Let's talk about a few class-related keywords. Static means the same thing as in Java. Basically, a static member is a member associated with a class rather than an object of the class. Another way to look at it is all objects of the class share the same static member. C# also allows us to create static constructors, which can be used to initialize static fields. And if a class only has static members, the class itself can be declared as static. This way, the compiler can ensure that no non-static members can be added to the class by accident, and no object can be created from the class by accident. C# has two similar-looking keywords for fields, constant or const, and read-only. Remember, we can use const on a variable, so the variable's value cannot be changed. When const is used on a class field, the value of the field cannot be changed. But in addition to that, it also makes the field static. This is the main difference between const and read-only. If you want a field that is constant but not static, you use read-only instead of const. Okay, now that we have covered the basics of C# classes, let's talk about a few class or class-like features, namely partial class, anonymous type, aka anonymous class, and the tuple. Partial class is pretty simple. Basically, it lets you to split a class into multiple source files. All you need to do is make sure that you have the partial keyword in each class definition. When the C# compiler compiles the project, it will assemble them into one class from different files. You probably won't use this feature often, but it's quite useful for certain tools. For example, later we'll learn Razor, which is a view layer in ASP.NET Core MVC, basically like JSP for Java. A Razor view is assembled from multiple pieces like layout, content, imports, and so on, and behind the scene it uses partial class to do that. Another class feature that you will probably use quite often is anonymous type. The idea is that sometimes we just want to create one object. In languages like JavaScript, we can do that easily like this without creating a class. If we want to do this in Java, it will take a lot more code. We'll first have to create a class car, then we need to create an object car, and then we need to set the properties of the car object to Honda and Civic. It's a lot of work if we just want to have one object. In C#, we can actually do something very similar to JavaScript. We can create a car object without creating a class first. Notice that this is basically the object initializer syntax we just talked about earlier, minus the class name or the constructor, hence the name anonymous type or anonymous class. If we compare the C# syntax with the JavaScript syntax, we can see that they are quite similar. In both cases, we just need to specify the property names and the property values, and that's about it. And in both languages, if we already have variables, we can just use those variables to form the new object, like this. Now, although the C# anonymous type syntax is quite similar to the JavaScript syntax, they are fundamentally different in one way. There's no real class in JavaScript, but in C#, an object must come from a class. So even though it seems like we are creating an object without a class, it's actually because the compiler automatically created a class for us. Note that the properties of this class are read-only, meaning that once we assign them a value, they cannot be changed. And because we don't really know or care the name of this class, we must declare the variable using the var keyword. The compiler can still infer the type of the variable because the compiler created the class, but we don't need to worry about the class name. So all in all, this gives us a nice and concise way to create an object for one-time use. And there's one more thing, tuple or tuple. Tuple is useful when we want to group a few values together. For example, Suppose we have a method that needs to return two values. We could use an out parameter like we talked about in the functions and methods lecture. The alternative is to put two values together into a tuple. The method can then return the tuple. Here are a few examples of creating and using tuples. The simplest way is to just put two values together. The compiler would infer that this is a string and string tuple. Of course, we can also declare the type explicitly. In both cases, we can access each property using the special property named item, like item 1 and item 2. If you don't want to call them item 1, item 2, you can give them specific property names, either in this form or in this form. And then we can use the property names to access the property values. The last one shows the case where we already have two variables. Similar to the anonymous type syntax, we can simply put the two variables together to form a tuple, and the variable names become the property names. Although tuples sometimes look like anonymous types, they have two important differences. Tuples are value types, where anonymous types are reference types. Also, because we can explicitly specify the type of a tuple, for example, string, we can use tuple type as the type for a method parameter or the type for a return value. But we cannot do that with anonymous types. Okay, this is the end of this video. Most of these are covered in Chapter 5 of the Pro C# 9 book. Please check it out. Thanks and see you in the next video.